Our notes for lesson 3.2 are going to start with some vocabulary. So these words, they're kind of big. Multiplicative inverse or the reciprocal. We're going to use those interchangeably. They mean essentially the same thing. So when we're trying to find the multiplicative, right, multiply by the inverse. Inverse just means we're flipping it. The opposite, right, of add is to subtract. The opposite of multiply is divide. So we're using the opposite of that. And then a reciprocal is just the same thing. We want to use the opposite of it. So the purpose of using a multiplicative inverse or a reciprocal is to have numbers that are related together whose product, and product means to multiply, equals 1. So we're trying to balance this out so that we're actually using a different, easier problem. Sometimes, right, numbers don't always nicely go into each other. Like 3 doesn't nicely go into 7, but if I can multiply them instead, 3 times 7, that's a lot easier to do than 7 divided by 3. So we're using the same numbers, we're using the same process, but we're just flipping it. And so instead of dividing, we're saying, oh, I'm going to multiply instead. But you can't just change the sign, right? If I have the problem 12 divided by 3, I can't just say, well, I'll just do 12 times 3 then. That's not the same thing. You've got to use that reciprocal and flip it, which we'll take a look at in just a second. So here's an example, right? We want to get this to equal 1. So we're using the same number. So the opposite of this, we flip it upside down, and I put 5 on the top and 3 on the bottom. Well, 3 times 5 is 15. 5 times 3 is 15. And this just means divide. 15 divided by 15 is 1. So when I multiply by so the inverse, multiply by the inverse, its opposite, I'm actually doing the same thing. 3/5 or timesing by 5/3 is the same thing. So I can just flip it to get that problem there. If I did this, 3/5 divided by 3/5. Well, this is a nice number because 3 divides by 3 one time, 5 divides by 5 one time. 1 divided by 1 is 1. But not every number is going to be nice like that. I might get a problem that says 3/7 divided by 2/6, right? 2 doesn't go nicely into 3. 6 doesn't nicely go into 7. So that's when we want to use that multiplicative inverse and we multiply by the opposite. So, right, taking this and I flipped it upside down. Either way, I came up with the same answer. So these are nice when the numbers are nice, but I like to use the multiplicative inverse when I have maybe not so nice numbers. And either way, right, it's balancing out. You're going to get the same answer. So let's take a look at a step-by-step process here. So the first thing we want to do is we want to write the problem down. So we're going to do the problem 12/18 divided by 3/4. 12/18 divided by 3/4. This is what we have. I have 12/18 of a pound of chocolate chips, and I want to put them into 3/4 pounds in a bag. Okay, so write down the problem. Here we go. Just like it read. This is what I have. This is what I'm dividing by. Next, you're going to use that multiplicative inverse. You'll hear me say some words. Copy, dot, flop. I know some of your teachers may have taught you keep, change, flip. Same thing, but we're using that multiplicative inverse. They really are just canceling out and saying this still equals 1, but now we can do the problem a little nicer, right? 4 doesn't go into 18. 18 divided by 4 is not a nice whole number. I can do 12 divided by 3, but 18 divided by 4 is not as nice. So I'm going to rewrite the problem. So I copy this first one down. So 12/18 dot for multiply. So the dot, I'm using the opposite of multiply, and then the inverse of the last one. So instead of 3/4, flip it upside down, and now I have 4/3. So here's my new problem. Step 3, we want to cross reduce if possible. Let's make these numbers smaller so that maybe we don't have so much work to do at the end and we have some easier numbers to work with. So I have 12/18, and now I'm going to times by 3/4. So I think it's important that we write down this first problem and then the second one, so we make sure we flip the right thing. This first one stays, and we change it to the opposite of divide is multiply, flip it upside down. So I notice that 3 and 18 have a common factor. 3 can go into both of them. 3 divided by 3 is 1. 18 divided by 3 is 6. I also notice that 12 and 4 have a common factor. 4 divided by 4 is 1. 12 divided by 4 is 3. So I'm just simplifying ahead of time. I could also simplify 12 and 18. So you're always doing one numerator to one denominator. You can't just do a cross. That doesn't work. I can't just simplify numerators. So 3 times 1 is 3. 6 times 1 is 6. So now I'm to 3, 6. Oh, I skipped some steps here. So multiply the numerators. 3 times 1 is 3. Multiply the denominators. 6 times 1 is 6. And then finally, we want to simplify if needed. So I have 3/6 right now. So I need to ask myself, is there a factor that is divisible by 3 and 6? Like I said that backwards. Is there a factor that can go into, there we go, 3 and 6? There is. 3 goes into both of these. 3 goes into 3 one time. 6 divided by 3 is 2. Right? So we took 3/6, and I said I'm going to divide this by 3 and this by 3, and that equals 1/2. So there's our final answer. Write the problem down. What is your original? Copy dot flop to use that multiplicative inverse. We could see back here. It'll give us the same answer. This just made it easier numbers. Oh, I've lost my words. Write down the problem. Use that multiplicative inverse, copy dot flop, keep, change, flip. Cross reduce if possible. It's going to make your life a lot easier. Multiply the numerators, multiply the denominators, simplify if necessary. So make sure you have all of those steps in the example written down to finish up your notes.